So some of you have already done this chapter, so you have some idea about what it is going on. Last year also you had this chapter periodic table. This year, majorly it's not periodic table, it's periodic properties and variation in properties. So let's have a look. Okay, so this is our periodic table with 118 elements. We have seen this previous year. This is the modern periodic table. Before this also, certain attempts of classification were done, but they don't have much importance now because this final periodic table has come up. So this is what we will study this year, and why this is important, how this helps us in understanding the periodic behaviors of element. Okay, some old points. This periodic table was formulated by Mosley. He arranged the elements in the increasing order of their atomic number. That is what happens in the modern periodic table. In periodic tables before this, you have studied that elements were mostly arranged. So in this modern periodic table, the elements were arranged in the increasing order of their atomic number. Unlike the previous periodic tables which we saw before that, the elements were arranged mostly in the increasing order of their atomic mass. So first time Mosley did this, that he was arranging elements in the increasing order of the atomic number. In this periodic table, there are 7 horizontal rows, which is called as periods. All right, and there are 18 vertical columns called groups. These vertical columns are groups, and these horizontals are periods. Again, here in the periodic table, there are totally 18 prominent groups. Like if you go vertically, a total of 18 groups. And majorly, we have 7 periods: 1, 2, 3, 4, 5, 6, and 7. What about these 2 rows? They are not separate rows. They are basically part of the group here, like this row here, the 6th and the 7th. Just few elements have been written at the bottom. Okay. Modern periodic law. Modern periodic law says that the physical and the chemical properties of elements are periodic function of their atomic number, which is again unlike the previous periodic table. This says it is periodic function of atomic number. See, this basically means that when you arrange your elements in the increasing order of atomic number, you will find that there is repetition in periodic properties, chemical properties, and physical properties at a regular interval of time. So the physical and the chemical properties will repeat at regular interval of time. Means after a regular interval, you'll find that you get elements which are having similar characteristic to the previous elements. So first period is shortest, which has 2 elements. The second and third period have 8 elements. Period 4 and 5 have 18 elements. 6 and 7, if you see, have 32 elements. Okay, that's the longest period. The 7th period, sometimes we say it's incomplete because if you look at the periodic table, there are 32 elements, but some of those later elements are synthetically prepared. So they don't really exist in nature, they're synthetically prepared. That's why we say 7th period is incomplete. The first group of element in the periodic table, that is on the extreme left, okay, is known as alkali metals. This group consists of elements like lithium, sodium, potassium, rubidium, cesium, and francium. What is valency of this group?
1 plus.
1 plus. As all the elements in this group has just 1 electron in the valence cell, their valency is 1. And therefore, okay, the valence electron is also 1. Okay, so here we need to also understand the difference between valence electron and valency. Valence electron is basically the number of electron present in the outermost cell, while valency is like the number of electron which is participating in a chemical reaction, either through giving, taking, or sharing. So valency is also 1 because all these metals, they generally lose their first electron. So briefly, like electronic configuration of lithium is 2-1, sodium is 2-8-1, potassium is 2-8-8-1, okay, and similarly rubidium would be 2-8-18-8-1, and similarly cesium is 2-8-18-18, 8 and 1. So we can clearly see that all these elements have 1 electron in their outermost cell. Therefore, their valency is 1. These metals are highly reactive, electropositive metal. Okay, so since they just need to give 1 electron, they are highly reactive because they can easily lose that electron and become more stable in their electronic configuration. So they are very likely to lose that electron. Sodium, potassium, rubidium, cesium, francium, all of them have explosive reaction in air and in water. Okay. In fact, as we go down, the reactivity increases. Like cesium being the most reactive. Francium is radioactive. It is not so well known. It's not found much in nature. It's very rare instances of francium has been known to mankind. So people have hardly seen francium. So we don't discuss much about this. Okay, so they're highly reactive and they're electropositive. What does electropositive mean?
Lose electrons easily.
They lose electron easily and form a positive cation. Like potassium loses electron, becomes K plus, sodium loses an electron, becomes Na plus, and so on. Okay, being metal, all the metals are good conductors. Sodium reacts with water to form NaOH. Potassium with water forms KOH. And same goes for the other elements of this group. That is why they're called as alkali metals. Next group is alkali metal, which is next right next to the alkali metal. The next group is alkali earth metal. This group consists of beryllium, magnesium, calcium, strontium, barium, and radium. Generally, these elements have two electron in the outermost cell. Like for example, beryllium is 2 comma 2, magnesium is 2 comma 8 comma 2, calcium is 2 comma 8 comma 8 comma 2, and so on. All of them have two electron in their outermost cell. Therefore, they have two valence electron. Their valency is 2, so they are called as divalent metals. Even these are highly reactive in nature because they need to lose two electrons. So if they lose two electrons, they would become stable. So they very willingly loses those two electrons. Though in comparison to alkali metal, their reactivity is less. So unlike alkali metal, which catches fire in the presence of water, they don't catch fire so often. Okay, so their reactivity is relatively less than alkali metal, but they're still reactive. And again, since they form positive cations like Ca2 plus or Mg2 plus, they are electropositive metals. Okay. Okay, in the middle of the periodic table, you have seen a group called as transition metal. Okay, so transition metals again have four periods. First three period doesn't have transition metal. It is the last of four group periods which have transition metal. Okay, these are all metals. They lie at the center of the periodic table. Right? There are two rows written right below the periodic table. These elements are known as inner transition metals. They are all metals. They are chemically very reactive and lie at the bottom of the periodic table. Then after the transition metal, the group is known as post-transition metal. So this is mainly from period 13 to 16 are called as post-transition metals. In this group, you will find that they are non-metals. Okay, this darker blue section is a non-metal, carbon, nitrogen, oxygen, phosphorus, sulfur, and selenium. Okay, this sky blue color, these are metalloids. Okay, again, metalloids are elements having property intermediate between metals and non-metals. Okay, while the green section over here, okay, below the zigzag line, these are all metals. The halogen series, which is also known as group 17. This group has 7 valence electron. For example, electronic configuration of chlorine is 287, fluorine is 27, bromine is 28187, and so on. So all of them have 7 electron in their outermost cell. Okay. Since they have 7 electron in the outermost cell, all these elements are looking for 1 electron. Again, these group of elements are highly reactive and they're electronegative non-metals. What is electronegativity? About that we will study in a while. These elements are good oxidizing agents. Why are they called as good oxidizing agent? Okay, about that also we need to know a little bit more this year. Okay, if you ask me briefly, what is a good oxidizing agent? A good oxidizing agent is a substance which easily pulls electron from other. Like all of them have 7 electron in the outermost cell, so they are eagerly waiting for 1 electron. So they have a tendency to pull electron from other elements. Hence, they are called as oxidizing agent. These are all non-conductor of heat and electricity. As they are not metals, they don't conduct electricity. Clear? Okay. I'm
So
going.
if
Yeah,
if
please tell me. Sorry.
halogens are oxidizing agent, then the first group, the alkali metals, then are they reducing agents?
Yeah, the first group is reducing agent. That's correct. Elements which give electron are good reducing agent, while elements which take electron are good oxidizing agent. Okay.
So basically, metals are good reducing agents and non-metals are good oxidizing agents
Yes, that's true. Okay.
because
Though this
they
is this. Yeah.
because
Sorry. Sorry.
metals lose electrons and non-metals gain electrons.
Correct. In fact, I will brief this for you because they may ask you a question on oxidation and reduction very often. So, see, briefly, what happens is metals and let's say non-metals. Mostly, okay. Obviously, we are not talking about metals which don't like to lose electron. Like gold does not like to lose electron. It is not reactive metal. But reactive metals and let's say reactive metals and reactive non-metals. Reactive metals likes to lose electron. Okay, while non-reactive non-metal likes to gain electron. Loss of electron is known as oxidation. Okay, loss of electron is known as oxidation. Gain of electron is known as reduction. Okay, so metals get oxidized by losing electron, and non-metals gets reduced by taking electron. But see, if you are giving electron, are you not helping the other person who is taking it gain electron? Right, means metal is giving electron to non-metal. So when metal gives electron, it is helping non-metal take electron. Okay, therefore it is called as reducing agent. Metals, since they themselves get oxidized, they help the other element get reduced. So they are good reducing agent. While non-metals, which are getting reduced, are good oxidizing agent. So always remember this. What itself gets oxidized is a good reducing agent, and what itself gets reduced is a good oxidizing agent. Clear?
Yes. Yes.
The last group, again a very important group, is group of noble gases. Noble gases have stable electronic configuration and they're chemically inert and unreactive. They're all monoatomic gases and their valency is zero. Okay, so briefing through, they are inert. Why are they called inert? Because they don't react with anything. They always likes to stay alone. Like for example, helium, unlike other gases, common gases like hydrogen, see, we know hydrogen stay in pair, nitrogen stay in pair, oxygen stay in pair, chlorine stay in pair. So all the reactive gases stay in pair, while helium stay alone. Neon stay alone. Like the neon gas is monoatomic, helium gas is monoatomic. Because they don't need to combine with another element. Clear? And their valency is zero. Okay. Next, period number. How many periods are there in the periodic table? There are total of 7 period, right? That's clear in the periodic table. Like there's 7 horizontal rows. So the period number, like for example, period 1, period 2, period 3, period 4, period 5, period 6. Period 3 have elements like sodium, magnesium, aluminium, and so on. Okay. So what does period number 3 signify in terms of these elements?
They have 3 orbits.
They have 3 orbits or 3 cells, right? So any element in period 3 or at till the end of period 3 will have maximum 3 cells only, 3 orbits or 3 cells. Cells and orbits are same. Okay. So any element till the end of period 3 will maximum have 3 cells. Any element in period 3 will have maximum 3 cells.
So
So
as we go down, the number of cells increases.
yeah, as we go down, the number of cells increases. Like for example, if I just consider the first group, hydrogen has only 1 cell. Lithium will have 2 cells. Sodium will have 3 cells. And every element in this period from sodium till the last element, okay, which is chlorine, oh no, argon, will have only 3 cells. Okay, none of them will have 4 cells. Then we go down further to potassium. Potassium has 4 cells. So the entire period 4 has maximum 4 cells. Okay.
Yes.
Same rubidium, cesium, francium. They have 5, 6, and 7. Sorry, 4, 5, 6, and 7 cells respectively. So if element is in a particular horizontal period, it has number of cell equal to the period number. Clear? This hydrogen, there is only one period. This is 2 period. This is 3 period. This is period 4. So every single element, starting from potassium till krypton, they have only 4 cells. None of them have 5 cells. Okay. Rubidium till xenon, they all have 6 cells. Sorry, 5 cells now. Cesium, barium, and then there's a discontinuity here because the elements are written below, lanthanum to lutetium, and then further to hafnium to radon. They all have 6 cells. Okay. Then francium, radium, actinides, okay, rutherfordium to oxyxenon. All these have total of 7 cells, and that is the maximum number of cell you have in a periodic table. Clear?
Yes, sir.
Okay. Next, what does group number signify? Group number generally signifies the number of valence electron. Group 1, group 2, okay, and then 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So in continuation, 13, 14, 15, 16, 17, 18. So what I said is group number signifies the number of valence electron, but not strictly. See, this is understanding you need to know. For example, group 1 element, they all have one valence electron. Like all of them have one electron in their valence cell. Group 2 elements have 2 valence electron. Sorry, potassium is 2881. So it has one valence 2882. So it has two valence electron. But what about scandium? Scandium electronic configuration is 28. Now we start filling the third cell because some more spaces are left in the third cell. So we fill one more here. So this becomes 9 and then 2. Okay. Same thing with titanium. This is 2, 8, 10, and 2. So if you go from scandium to zinc, finally for zinc, zinc is 2, 8, 18, and 2. So we are not filling the last cell. We are filling the penultimate cell, like the second to last cell. Whenever we move in this transition metal group now, we fill the remaining places of the previous cell. But what is happening is, see, logically also we know no, the third cell has 18 electron capacity, right? But then till calcium, we filled only 8 electron. So probably the remaining 10 will get filled sometime later, right? So that happens during the transition metal period phase. Okay. And that is true for all the periods. Okay. In all the periods, like for example, here, okay, see in calcium, this is 2, 8, 8, 2. And then we start filling after calcium from here till here, we fill the remaining places of the third cell till it becomes 18. Okay. Even for same happens even in the fifth period. From here to here now, we would be filling the remaining places of the fourth period. Okay. So here I will like to point one thing. Fourth cell does not mean that you are going to fill only the fourth cell. You might even fill the third cell. So here we fill the remaining places of the third cell. In fifth period, we can fill the fourth cell also. Okay. Because here we are filling the remaining places of the fourth cell. Same thing goes here. Here we are filling the remaining places of the fifth cell. And here we fill the remaining places of the sixth cell. You're getting my point? The previous cell. Is that clear?
Yes, sir.
But the maximum cell would be same as the period number. Sorry, something happening. So group 1 and group 2 has maximum 1 and 2 valence electron. Okay, but when it comes from group 3 to 12, they also have generally two valence electron. Okay, there are few exceptions. I will not get deeper into that because that's completely out of our syllabus. But they have generally two because we are filling the remaining places of the previous cell. Okay, then when are the remaining elements of the of the last cell will start getting filled? They start getting filled from 13. So for example, gallium here, electronic configuration is 2, 8, 18, and now 3. That means group 3, all of them will have, group 13 will have 3 valence electron. Okay, please remember this. Question comes on this. Group 13 has 3 valence electron. Group 14 will have 4 valence electrons similarly. Group 15 will have 5 valence electron. Group 16 will have 6 valence electron. Group 17 will have 7 valence electron. And group 18 have 8 valence electron. Obviously with the exception of helium, which has only 2 valence electron. From neon onwards, they have 8 valence electron. Is this clear? So group number signifies the number of valence electron, but it is not equal to the valence electron always. Okay, so I just wanted to specify that point. It is equal to the valence electron in group 1 and group 2, but not in case of the post-transition elements. In case of post-transition element, group number is follows a similar pattern, but it's not exactly the same. Like group 13 has 3, 14 has 4, and so on. Horizontal row in a period are called as, we'll quickly deal with this. Okay. What is horizontal row in a periodic table called as?
Periods.
Period.
Periods. Okay. On moving from left to right in the second period, the number of valence electron, when we go
Increases.
from left to right, valence electron increases. If an element has one electron in its outermost energy cell, then it is likely to be,
Cation.
No.
Lose the electron.
if an element has one electron in its outermost energy level, then what is that element?
A
As
metal.
A metal.
Yeah, so what is that metal?
Alkali metal.
Alkyl metal, yeah. If an element has one electron in its out, okay, so this is an alkali metal. The property of an element are a periodic function of their,
Atomic number.
the elements sodium and chlorine in the same dash of the periodic table.
Period.
Are in the same
Period.
period of the periodic table. Vertical columns in a periodic table are called as
Groups.
groups. Okay. Okay, how does the valence electron in an atom changes in a period from left to right?
In a group, in a
In a
group,
period.
number of
It valence electrons.
In a period from left to right. How does it change?
as I think from metals to non-metals they do change.
No, just think of a period. You're going from left to right in a period, in any period. So, what happens to the valence electron, the outermost cell? They increases or decreases?
Increases.
That's all they're asking. Increases. Understood?
Yes, sir.
Yes.
In a group from top to bottom,
Stays the same. No?
Say same.
stays same. Okay. Elements in the same period have same valency. We need to correct the
Elements
statement.
in the
In
same
the
And in the
same,
same period have the same valence electron
No, no.
Can we
or
say
have the
elements in
same
the
number
same
of
group?
orbits.
in the same group have
Number of
the same valency.
Yeah, so we correct valency to what?
number of orbits.
Number of orbits. Okay. Okay. So valency depends on the number of cell in. What's the correct answer? Does valency depend on the number of cell in an atom?
No,
Then what does it depend on?
The
valence electrons in an atom.
Valence electron. Okay. Copper and zinc are representative elements. No, they're not representative elements. Okay. They are better called as transitive element. What is representative elements? Not so important. So they are transitive element. Identify them. Transitive elements are placed at extreme right of the periodic table. Is that
They
true?
are placed in the center of the.
Center.
Center. Fluorine, chlorine, bromine are put in one group on the basis of their similar property. What are those similar properties?
They are
Yeah,
halogens or
Halogen.
non-metals.
they're non-metals. Okay, one property.
They have 7 valence electrons in the outermost shell.
7 valence electrons. Okay,
They gain an electron.
they gain electrons, so they are electronegative in nature, about which we'll study later. Then
they are halogens.
we can put many. They are good oxidizing
Good
agents.
oxidizing agents.
Okay, what is the common name of the group or the family?
Halogen.
Okay. Okay, an element has 2 electrons in the n cell.
Fourth cell.
KLMN, fourth cell. KLMN, fourth cell. What is the atomic number?
20.
2882. Right, fourth cell is 2, so it's atomic number 18. Sorry, atomic number 20, not 18.
It's calcium.
This is
Calcium.
calcium. So okay, so is it a metal or non-metal? Obviously it is a metal. State the name assigned to
Metal.
the. What is the position in the periodic table? So when they say
Period.
position,
It's in
okay,
Period 2 group. Okay, period 3. I 3.
period,
Wait.
Period 4.
period 4.
period 4
Group 2.
Oh, period 4. Yeah.
and group.
And
2.
Group.
2.
Okay, yes. So like just count the number of valence cell. Sorry, number of cells. So fourth period, 4. Okay, and since there are 2 valence electron, then it's group 2. It's a metal, sure. Name assigned to the group.
Alkaline earth.
Alkaline earth metals.
Okay, such follow-up questions also come a lot. 1 marker. Okay, answers are never long in chemistry, but like follow-up questions like, what is valency of this element?
2 plus.
2 plus. Okay, good. Okay. Now, table-based questions are also very common in this chapter. Okay. So here you have a small table where the atomic number is written at the top and the elements are written with some random symbols. These are not the original symbols. These are just random symbols assigned to them. Now, while answering any of these questions, these kind of questions in your board examination, make sure that even if you're able to identify the element, try not to identify them. Okay. Because that might be counterproductive. So the question refers to the elements of the periodic table with atomic number 3 to 18. Some of the elements are shown by letter, but the letters are not usual symbol of the element. They've specified this point. Okay, now looking at the periodic table, you have to tell which of these is a noble gas.
P.
The
P.
P.
Okay, P. Only P?
Uh, yeah.
Yes.
There is no noble gas before P, atomic number 18? Is atomic
Oh,
number
oh,
18?
F. F.
Uh-huh.
F.
Yes. Which one, Krishansha?
F.
F has atomic number 8, which means it has 2, comma 6 electronic configuration.
Isn't it like only 18?
Yeah.
H. H. H.
H would be then see H is atomic number 10. That means 2, comma 8. This is neon. Okay. But don't try to identify neon. That's not important. Okay. So it's P and H.
Oh.
Atomic number 2 is not there. So we can ignore 2. It starts from 3 onwards. Otherwise, if 2 was there, then that helium also we need to include. So 10 because it's 2, comma 8, and 18 because it's 2, comma 8, comma 8 is a halogen.
17, 11, and 3.
17.
17 is okay, which means O. Then
9.
3.
9.
9, which
G.
is G, is okay.
Oh. Okay. Sorry.
11 is sodium technically, so that's not okay. Uh, do we have
I
more?
think that's it. That's it.
That's it, right? Okay, fine. Alkali metal. Which is an alkali metal?
A.
3.
Yeah, atomic number 3, lithium, which is represented as A here, and
11. I.
11. Okay, 11 is potassium represented with symbol I here. Okay, that's it because atomic number 19 is not there. Okay, which element has valency 4?
D.
D. 6.
And L.
And okay, atomic number 14, L. Understood.
Yes.
Okay. Okay, this is a bit of a recap of last year, so let's just try it out. Write the atomic number and the electronic configuration of elements A, B, and C. Okay, so we'll write electronic configuration right here above the element. Mass number is 23 and the number of neutron is 12. So I think first we need to find the number of protons. How many protons are there in element A? Protons or electrons? Either.
11.
11. B.
10.
10.
Okay. And C?
17.
17.
17.
70. Okay. So we first find the protons or the electrons and then we write the electronic configuration. So 11 electronic configuration would be,
281.
1.
okay, 10 is,
2, 8.
28.
this is 28.
287.
Okay, good. So we have written the atomic number. Atomic number is same as proton or the electron. This is atomic number Z. Okay, now to which group do A, B, and C belong? So A belongs to which group?
Alkaline.
Group number? Like
1.
group
1.
number?
Group number
Group
1.
number 1. Okay, B,
Uh,
Group number
Noble gas is
noble gas. So what is that group
18.
number?
8.
18.
18.
18.
Yeah.
Halogen
And
17.
70.
17. So if it has 7, 17. 8 valence electron, 18. 1 valence electron, 1. Like that, you need to answer. To which period do A, B, C belong? A belongs to period
3.
3. B belongs to period
2.
2.
and C belongs to period
3.
3 again. Which among A, B, and C is an alkali metal?
A.
Is a noble gas?
B.
B.
Is a halogen?
C.
C.
Okay, just a few more. An alkali metal in period 3 and a halogen in period 2. Name.
An alkali metal in period 3 is
Sodium. So now,
sodium.
yeah, sodium. Sodium.
Sodium. And halogen in period 2.
Uh,
Chlorine.
yeah, fluorine.
Fluorine.
Fluorine. The noble gas with 3 cells.
Argon.
The non-metal present in period 2 and the metal in period 3.
Non-metal.
Metal.
Oxygen, nitrogen.
Okay, so there are plenty oxygen, nitrogen,
Carbon. When
And the metal in period 3,
Sodium, lithium,
sodium, not lithium, sodium, magnesium.
and sodium.
Okay. The element in period 3 with valency 4. It's a good way to learn our periodic table. An element in period 3 with valency 4.
Phosphorus,
Silicon.
silicon, yes, silicon.
Silicon.
silicon
2,
is
8. Yeah, so that's fine. It's an element, right?
high.
Element in period 3 which does not form oxide.
Can it be the noble gases?
It must be the
Argon,
noble gases. You know
argon,
why? Mostly any substance which is reactive, no, they very easily combine with oxygens. There rarely there might be substances which is reactive and they don't combine with oxygen. So period 3 elements, all those which are reactive will certainly combine with oxygen. Okay, so they form oxides. So only like because oxygen is one of the most reactive like non-metals, so it tries to combine with almost everything. So only thing which will not form oxide would be a noble gas. So noble gas in period 3 is 288.
argon.
Element of lower nuclear charge out of beryllium and magnesium.
So what do you mean by lower nuclear charge?
Okay, nuclear charge basically means which has less number of protons, positive charge in the nucleus.
Very low.
Beryllium.
Beryllium. Okay. So electronic configuration of the element T is 2881. What is the group number of T?
One,
One.
One.
Okay. What is period number for T? 4. How many valence electron are there in an atom of T?
one,
One.
What is valency of T?
One.
one plus.
Plus one.
Plus 1. Is it a metal or a non-metal?
Metal.
Okay.
Metal.
Metal. Here few atomic numbers are given. We need to match them with the correct explanation below. Which metal has valency 1?
19.
19, because electronic configuration for 19 is 28.
288,
Good. Solid non-metal of period 3,
Uh,
15,
15. It has to be between 15 and 19 because the rest are in period 2 or 1. So it is, it's a non-metal, so it has to be 15, 285. That's phosphorus. A rare gas.
is it?
Noble gases are rare gases,
two.
most of them.
2.
Helium. Actually, helium is also called as rare gas because it's hardly present in our atmosphere. It is said that it is so light that it escapes out in the atmosphere. Even if some helium is released in the atmosphere, it escapes into outside the atmosphere. It escapes outside the atmosphere. Okay. The gaseous element with valency 2,
8.
8. 8 is 2 comma 6, right? So that is oxygen.
Yeah.
Okay. The element of group 2,
4,
4, because it is 2 comma 2. So that's 4. Okay. So that's fine.
Yes.
Yes, sir.
Okay, so we come to the end of that part. So I hope you understood all of them. If you really followed the discussion of the questions, I think you may not even have to revise much with that. Okay, as problem solving, I think is the best way to recap these topics. Okay, so we'll go ahead with maybe one or two periodic properties. At least we'll do one for today. Okay, it's a small chapter. I think 2 sessions would be more than enough to complete this. So periodic properties are in fact the most important part. Okay. So the properties which appear at regular interval in periodic table are called as periodic properties. The phenomena is called as periodicity in the properties of element. So see, now that we have made a periodic table, now that elements are organized in groups and periods, there was a reason behind doing this. This is not just like that. Okay, there was a reason behind doing this. Now that we have a periodic table and we see that elements are arranged in groups, when I look at like more particularly at elements in a given group like lithium, sodium, potassium, okay, rubidium, cesium, and francium, when we observe elements of any given group, we see that there's a lot of similarity in their chemical and physical behavior. Okay, So they're very alike in terms of how they react with other elements. There may be gradual increase in those properties. Like for example, all of them are reactive, and the reactivity further increases when you go down. But they're all very reactive in compared to other metals. So we have seen that there's an advantage which comes with classifying elements. Now we have elements arranged in proper groups where all the elements of a given group have similar properties. So this kind of similarity in properties at regular interval is called as periodicity. And that is the main advantage of making this periodic table, that we can achieve periodicity in property. Okay. And the properties which repeats. Okay. Like what can be the properties which repeats? Properties like atomic radius. There's a pattern which you can tell with the periodic table. There are properties like ionization potential. Okay, these are periodic properties. They repeat at regular interval, and there is a specific manner in which they change when you go left to right in a period, or you go top to bottom in a period. So the properties which appears at regular interval in a periodic table are called as periodic properties. The phenomena is called periodicity in the property of the element. Okay, why there is periodicity in periodic table? After definite interval at atomic number, like after definite interval of atomic number, you find that there is similar valence cell electronic configuration. Okay, like after a regular interval, you find that all the elements which lie in the same group, they have similar valence electronic configuration. Similar valence electronic configuration means they have same number of valence electron. All right. So that is one reason they have similar or there's a periodicity in property, because they depend on their valence electron and their valence properties. Properties of elements depend on the number and the arrangement of electron in various cells, including the valence cell. Okay, so that is also responsible for periodicity. They have similar arrangement in the. What are the periodic properties which we are going to study in this chapter? The most important periodic property is atomic radius. In fact, this is so elemental that if you understand this, the other periodic properties can be explained, or their pattern can be explained in terms of the first periodic property. All right, so that's most important. Like we understand how the atomic radius changes. If we understand that, we can actually explain the periodicity in other, periodicity pattern in the other periodic properties. Okay, other names also I think you've already become familiar with because you've already done in school. So it's ionization potential, electron affinity, electronegativity. So we will look in detail what each of these term means. Then non-metallic and metallic characteristic, and so on. First, atomic radius or the atomic size. Please don't get confused, it's the same. Because I think we know that atoms are mainly spherical in shape, and the one which has greater radius is also bigger in size. So atomic size and atomic radius means the same. So the distance between the center of the nucleus of an atom and its outermost cell is called as atomic radius. What are the factors which are responsible for atomic radius? The first factor which is responsible for deciding the atomic radius or atomic size is the number of cell. So logically, if you have more cell, you will have more, like size would be greater, right? Like for example, lithium has 2 cells, so it's smaller. Sodium has 3 cells, so it's bigger. Potassium has 4 cells, so it's bigger, right? So more the number of cell, more will be atomic radius. So I can say number of cell. Atomic size is directly proportional to radius is directly proportional to number of cell. Okay, but there's another factor which comes in, and this is something unique, I think, which you're learning for the first time. Okay, atomic radius also depends on the nuclear charge. Okay, as I discussed in the previous question, one of the question, nuclear charge means how many positive charge it has in the nucleus. Okay, so to understand this
So
better,
the
like
main charge, the number of protons present in the nucleus.
yeah, that is nuclear charge. Like for example, sodium has like sodium atom, it has 11 protons. It has 11 positive charge in the nucleus, and how many cells it has? 3.
3.
Same, magnesium has 12 protons. And how many cells this has?
3.
3. Atomic number for sodium is 11 and magnesium is 12. Like, what is your guess on which is bigger in size? Is it sodium or magnesium? You can guess. There's no harm in guessing.
Magnesium.
Magnesium.
Anisha thinks it's magnesium. We have 2 votes for magnesium. Nishika, which is bigger?
Even I told magnesium.
Okay. And Maria, what is your guess on this? Are you there, Maria?
Yes, sir.
Yeah. What is your guess on this? Which is bigger, sodium atomic number 11 or magnesium atomic number 12
Magnesium?
is bigger than sodium?
Yes.
Okay. See, trust me, that is what I used to think as well. Before I studied this chapter, obviously that's long back, but I'm pretty sure that is what my understanding was about this. That sodium has 11 proton. Okay, so sodium having 11 proton uh, must be smaller in whatever ways. It should be smaller because it has one less proton, one less electron. So that was my logic of looking into it, that it must be smaller than magnesium. But see how it happens in chemistry is sodium has 11 proton, means it has 11 positive charge, while magnesium has 12 positive charge, and the electrons are distributed in the same three cells. Okay, protons are in the center, in the nucleus. Okay, if the nucleus is strongly positive, it will pull the cell towards itself with greater force, means it will try to shrink the cells inward with greater force. You're understanding my point?
Yes, sir.
This is what it is known as nuclear charge. So greater the nuclear charge, there is like the atomic radius technically decreases.
Okay.
So that means when you go from left to right in any period, atomic size reduces and not increases.
Yes, sir.
So this is sodium, which is the biggest member of period three, two, period two. Oh, that's not sodium. Sorry, my bad.
So
Yeah,
our teacher told that when we go down, the,
yeah,
that atomic size increases because the number of shells they
increases.
dominate
Correct.
over the nucleus, so they increase.
That is logical. That makes sense. Even if my teacher won't say that, I will believe, right?
Yeah, but why does this size decrease when we go like left to right?
Yeah, that's what I'm trying to explain. You see, when you go from left to right in any period, lithium, uh, okay, lithium, beryllium, boron, carbon, nitrogen, the size is becoming smaller and smaller. Oxygen, fluorine. Okay, just here, neon is slightly bigger. Okay, that is not the inner portion, but I'll explain you that also. So when you go from period 1 till period 17, sorry, group 1 till group 17, size decreases. Okay, group 18 is slightly bigger. There's a different reason for that, which I will let you know later. Why the size decreases from lithium to fluorine? So the simple reason is if they ask you why the size decreases from left to right in a period. So when you go from left to right in a period, number of cells remains the same. You have same number of cells, means all of them have two cells, right? Okay. And who is holding them together? It's the nucleus in the center, which is like holding them together. If the nucleus in the center is more positive, more stronger, they will pull these cells with a greater force inwards. Okay, it is not much to do with the number of electrons present in these cells. It's more to do with how many cells are there. Okay, so if they ask why in a given period atomic size decreases, you need to say that in a period from left to right, number of cell remains same, while nuclear charge increases. Therefore, atomic radius decreases.
So is this because of the attraction from the
Yeah, see the cells, no, the two cells which are there, nucleus pulls them with greater force. So it shrinks them inwards. Makes sense, sir?
yes, sir.
So this diagram you see is a good representation of what is happening. Sodium is biggest, and then is magnesium is smaller. Aluminium is even smaller. Okay, silica is even smaller. So if they ask you which is the biggest element in period three, which is the biggest element in period three?
Sodium.
It is sodium. Okay.
So the nuclear charge is inversely proportional to atomic radius.
Yes, sir. If at all you have this doubt, if they come that sir from sodium to potassium to sorry sodium to potassium also nuclear charge is increasing, then why the size is increasing? It is because of addition of an extra cell. So when a cell gets added, no, that that overcompensates the nuclear charge factor. Okay, means like this is a cell size. When you go from left to right, it's decreasing, decreasing, decreasing. It's becoming smaller. But then when you go to the next next period, now there's a bigger cell which is getting added, which overcompensates the shrinking factor. Okay, make sense?
So if the number of shells increases, the nuclear charge will decrease.
No, nuclear charge increases because sodium has 11 protons, potassium has 19 protons.
Oh,
So
nucleus.
nuclear charges increases. Then if suppose they ask you a question like this, potassium has 19 nuclear charge, sodium has 11 nuclear charge, then how come potassium is bigger than sodium? They can ask question like that, right? So
Yes, yes.
what do you explain for that? So you say that it's true that nuclear charge increases from sodium to potassium, okay, but since there is addition of cell, okay, there's an addition of cell, the addition of cell factor overcompensates the change, the decrease in increase in nuclear charge. Okay. So a bigger cell gets added. So even the smallest, the inner cell became very small. The new cell overcompensates that. So that leads to the increase in radius. Which is the biggest element therefore in the periodic table, which has highest atomic size?
So that's the period 7 group 1 element,
Group 1 element. That is francium.
francium.
Okay. Since francium is rarely found, now it's clear that left to right, the atomic size decreases, top to bottom, atomic size increases. So the biggest elements lies somewhere in this column, and the smallest lies in this column. So I think helium is the smallest element. Okay, among others. See, as far as the noble gas thing is concerned, if suppose they ask you a question, generally boards reframe, like try not to ask those very those specific question where there's there what do you call, there is element of confusion involved. Like for example, the general trend is from left to right, atomic radius decreases. But if I ask you specifically, which group has like in period 2, for example, which is the smallest element? In period 2, which is the smallest element? It's not argon, it is fluorine. Okay. Such questions I've seen in board, not in board paper, but in pre-board paper. So keeping that in mind, as a teacher, it's our duty to just let them know. These are there in higher classes. So for any period, for any period, if they ask you which is the smallest element, write the halogen of that period. Don't
Yeah,
write the
any
noble.
reason? Any
Any
reason?
reason? Okay. The reason for that is
So that we don't get confused.
I'll explain you, no problem. See, there's another factor which governs the radius, but we haven't spoken about that yet because that's not significant till now. But when it comes to noble gases, that factor also becomes significant. Then what is that factor? See, what happens in an atom, atomic size depends, as I said, in a given period on. Okay, so that is the major factor till group 17, which explains the pattern. But when more and more electron comes in a given period, the electronic repulsion also increases, and the electrons also try to be away from each other as much as possible. Okay, so both the factors are playing a role, right? One is that nucleus is pulling them strongly as it's becoming stronger when you're going from left to right. That is one factor. The other factor is, since you're adding more and more electron in the same cell, the electronic repulsion is increasing, and hence the electron are trying to move a bit away from each other. But till now, the nuclear factor was a stronger factor till group 17. Okay. But when it comes to group 18, all of a sudden the last cell gets completely filled, and there's a lot of chaos now here in the last cell because of extremely dense electron cloud. Means there's a lot of electron now there. So therefore, in the 18 group, when there's 8 electron in the outermost cell, that time the electronic repulsion factor over exceeds, or it exceeds the nuclear factor. Are you understanding my point? Okay. See, it's very similar to, sir, I study hard for exam, but I'm also casual at times. But I'm casual less, mostly I'm serious. So the serious factor is governing my result till now. But the day my casualness increases more than my seriousness, then that becomes a major factor in deciding my result. So that's what is happening here. The repulsion was increasing even from year to year, but the nuclear factor was a stronger factor till then. But from 17 to 18th, the electron become like 18, the 8 electrons. So now the repulsion is really high. Okay, so the nuclear factor is not able to overcome that. So therefore, there's a slight increase in radius from 17 to 18. Nuclear factor tries to reduce it, but the repulsion factor increases it more than what nuclear factor reduces it by. Clear?
Yes, sir.
So that's, I think, a proper explanation for that. Okay, moving further. So this is the trend, what we learned. Atomic size, it decreases across a period from left to right, and atomic size increases down the group. That's all about atomic trend. So atomic size dash as we move from left to right across the period because the dash.
Decreases.
So this decreases because the
Nuclear charge increases.
nuclear charge increases, but the
Orbits remain the same.
number of orbits or number of cells remains the same. If an element has 7 electrons in the outermost cell, then it is likely to have
The least atomic size.
among the element in the same period. Okay, so 17 has the least. In period 3, element B is to the left of the element C. B is to the left in the same period. The atom of B would be expected to be bigger or smaller.
Bigger than
Correct? So such questions might come on this. Just a last set of questions on atomic size. An atom or a cation, which is bigger in size, which is greater in size? Now, again, this is not the in board examination, but I have seen this question multiple times in pre-board papers. Okay.
cation.
Okay, let's think like sodium and sodium plus, which is bigger?
Sodium plus. No. Sodium.
Sodium.
Let me explain you. What happens in sodium has 11 proton, it has 11 electron.
Yeah.
And it also has 3 cells. Sodium plus has 11 proton, but it
10
has
10
electrons.
electrons. So
Because it has lost an electron.
yeah, so it's an atom is larger.
So it's Na plus because
see there's two thing way of looking at it. One is this is 281 and this is 28. This has 3 cells, this has 2 cells. So this is smaller.
Yeah.
That is one way of looking at it. The second way of looking at it is that now for 11 proton, they only have to pull 10 electrons. So they can do that with greater force, right? So they will try to shrink them more. So it will be smaller. Yeah, Na plus is smaller. So greater is atom, correct?
yes.
An atom or an anion, like for example, chlorine or Cl minus, which is
I think anion.
anions, right? So calcium has 17 proton, 17 electron.
So 2 8
This one has 17 protons, but
18.
18 electrons. Nuclear charge is same for both, but now it needs to pull a greater number of electron, right? So, like if the nuclear has to pull greater number of electron, its capacity.
It'll take some time to pull it towards itself.
Yeah, time or its effort will get distributed more, right?
Yes.
Among the 18 electrons. So it won't be able to pull them that efficiently. Okay. So yes, so it is an ion which is bigger. Okay, same with Fe2 plus and Fe3 plus, which has more electrons.
Fe2.
This has lost 2 electrons, this has lost 3 electrons. So 2 plus has more electrons. Since it has more electrons,
It's
the
greater.
size would be greater. Okay, this is greater and this is smaller. Okay, so even if you have to compare between atoms and cations, this is a way of looking at it. Okay, see you then. Thank you and bye.
Bye.
Thank you, sir.